This video is on the preparation of hydrocarbons. Hydrocarbons or alkanes tend to not be that exciting. They're literally compounds lacking functional groups. But sometimes you might have an extra functional group that you need to get rid of. Well, hopefully that functional group is a good leaving group like a halide. How do we make the hydrocarbon or remove the leaving group? Well, we got to replace the leaving group with no functional group, i.e. with a hydrogen. Well, that means that we need a hydrogen nucleophile, i.e. a hydride, H-. This reaction is only good for primary and secondary carbons and is most often used, as mentioned prior, with alkyl halides. The most common sources of hydrides are lithium aluminum hydride and sodium borohydride. Both of these molecules have a hydrogen bonded to an atom that is less electronegative than hydrogen, and therefore the partial negative charge lays on the hydrogen. Lithium aluminum hydride is way more reactive, but it reacts violently with protic solvents or any acidic protons present. The hydride will react with the protons to form hydrogen gas, and the heat that is generated along with the reaction will ignite the hydrogen, so you have a mini Hindenburg in your reaction vessel. Sodium borohydride, on the other hand, is less reactive and can be used in the presence of protic solvents, but not in acid. Either way, if we took this 2-bromopentane and mixed it with lithium aluminum hydride in a diethyl ether, we would end up with just pentane. Now you have a go. What would be the products of these following reactions? You may pause now. And here are the answers.